Hi guys, welcome back to my channel Pirai Academy. In this video, we are going to see about a Leetcode question number 516, longest palindromic subsequence. Given a string S, find the longest palindromic subsequence length in S. So they are not asking us to find the subsequence, they are asking us to find its length only. Okay. Now, a subsequence is a sequence that can be derived from another sequence by deleting some or no elements without changing the order of the remaining elements. So this is called subsequence. Okay. For example, if the given string is B, B, B and AB, then I can tell you I have a longest palindromic subsequence of B, B, B and B, 4. So this is going to be your output, right? Similarly, here also B and B is going to be your output. Rather than this, there is no other longest palindromic subsequence, right? Fine. Now, okay, so in your real-time technical interview also, they will be giving you the sample cases like this. Okay, they don't want to reveal too much information to you, so that you will be you can't able to go with one particular approach. Okay, they will be collapsing you by using these kinds of sample test cases, while in hidden case they will be using edge cases. Okay, fine. So whenever there is a longest, smallest or maximum, minimum, then we are going for a greedy algorithm, right? Okay, so I'll be starting like this and this. Okay, so from starting one point and ending one point. Okay, 2 pointers I am using. Now this and this, whether these both are same? Yes, they are both are same. Okay, so why I am taking like this? First of all, the palindrome means it is like the first and the last character are same, and second and last front character are same, like that only. That's the reason I am taking like this, my pointers. Okay, now this S and this S are same. Okay, 2 plus. Okay, now I'll be going to next point. Oh, here they both are not same. Here they both are not same. So whenever it is not same, I am going to move my front pointer to here. Now they both are same, right? 2 plus, here goes and here goes. Now both are pointing to R. Okay, whether R I should be taking 2 times? No, I want to take only 1 times, right? So 1 is equal to 5. So 5 is going to be my output. Okay, now just apply the same greedy algorithm here also. Now these both are same, 2 plus. Now come here, A and T, they both are not same. So what is our next thing? I will be moving my front pointer one step ahead. R and T, no. A and T, no. T alone, yes. 3. But I want my output as 5 if I take SA or AS. Can you understand this? So where my greedy algorithm is failing when both the both the characters are not same. Then my greedy algorithm failing, right? So I cannot decide whether I want to move my front pointer or I want to move my back pointer. In this example, if I moved my back pointer, then it is correct. Right? So for this only, we are going for a recursion and backtracking solution. Can you understand this? So I want to go for all possible combinations. Then I will be picking the good one. Okay. So the prerequisite for this particular approach is you want to know about recursion and backtracking. If you don't know about the recursion and backtracking, don't worry. I'll be giving a link in the description. Just go and watch that video and come back here. Okay. Now, whenever it is a recursion, the first thing I want to do is my function. So what are the varying parameter I want? I want 2 varying parameter here, the 2 pointers, right? So let me write the string stars 0, 1, 2, 3, 4 and 5. Okay, now where should I start? I should be starting from 0, 5. Okay, whether 0th index and 5th index are same? Yes, they both are same. Whenever it is same, I can take both the things and move one step ahead. Here also one step ahead. Okay, now 1, 4. Whether this T and this A both are same? No. Whenever it is not same, I have 2 choices. Either I can go to here or I can either go to here. Simple, right? Now 2, 4, which means this A and this A. Whether these both the things are same? Yes. Then I will be going to 2 plus f of 3, 3. Now 1, 3 means it will be T and R. They both are not same. So go to the next thing. 2, 3 and here comes 1, 2. Similarly, now see here, 2 comma 3 means what? Sorry, 3 comma 3 means what? My front pointer is at R and my rear pointer is also at R. Okay, which means I only taking R as my current value. I only taking my R as my current value. Whether R is a palindrome. Yes, it is a palindrome. It is a palindrome of length what? 1. So instead of this, I will be replacing as 1. Okay, so this is one of the base condition. If I and j are both are equal, then just return 0. Sorry, just return 1. Okay, so this is one of the base condition. Now from here also it will be returning 3, because here it is 2 plus 1 which is equal to 3. So here it will be returning 3. Okay. Now similarly here 2 comma 3 both are not same. So whenever it is not same, I have two choices. Either I can go to f of 3 comma 3 or I can go to f of 2 comma 2. Here also I have two choices because 1 and 2 are not same. T and A are not same, right? So here I can go either to 2 comma 2 or I can either go to 1 comma 1. Okay. Here also it will be returning me 0. Sorry, returning me 1. Returning 1, and here 1, and here also 1, and here also 1. So you may ask, hey, instead of this, I may go greater than j also. May go greater than j also. For example, if I is at this particular point and j is at this particular point and both are equal string, then how it changes? J comes here and I goes here, right? So for this, I just return 0. What it signifies? Hey, the string is already completed. There is no remaining string. So don't do anything. Just return 0. Now here one of my recursion call is returning 1 and another one is returning 1. So from these, which should I take? What is they are asking in the question? They are asking us to find the longest. Okay, so I want to take the maximum. So what is the maximum? It is 1. So instead of this, I will be returning 1, and here also I will be returning 1. Among this also again 1. Now 3 or 1, which is maximum? 3 is maximum. Okay, so instead of this function, I will be replacing as 3. Now return 5. Again here I will be returning 5. So 5 is going to be my output. Okay, now tell me what is the time complexity? So time complexity will be O of 2 power n square, and space complexity is going to be O of n square because of the recursion stack. Fine. So let us see the code. The code is in Java. If you want C++ or Python, just go and search in the description. Okay. Fine. So see here. Here it is 0 and n minus 1. I am starting from 0 and n minus 1, and two base condition. If I is greater than j, I want to return 0. If I is equal to j, then I want to return 1. Then if both the I and j element is same, then I want to return. Then I want to go to what the recursion call. It is 2 plus the recursion call of I plus 1 and j minus 1. Okay. Else I want to take the maximum among I plus 1 comma j and j I comma j minus 1. Okay. That's it. So this is going to be your entire recursion code. Now this recursion code will be showing you the time complexity error, right? Because here it is 1000. The length is 1000, which means 2 power 1000 is exceeding 10 power 9. That's the reason why it is showing you time complexity error. So what I am going to do next? So the next thing is I want to go and optimize it. So how I am going to optimize it? I am going to use the memoization technique. So just see here. Second thing is memoization. So what is memoization? So basically, whenever I computed some values, instead of returning it directly, I will be storing in my memory, then only I will be returning it. In future, if it is again repeating, then I don't want to go for all the recursion calls. I will be just taking out from my memory itself. Like, see here it is 2 comma 4. If in future again it is 2 comma 4, then I don't want to go for all the recursion calls. Instead of this, here itself I will be storing in my memory, so that here I will be returning it from my memory. Can I understand this? So this is what called the memoization technique. Now here I can either do this by using hash map or array, but I suggest you to do with array. Okay, if you are doing with array, then it is easy to do with the hash map also. Here I will be using the array approach. If you want, you may go and try the hash map approach also. It is going to be very easy. Now what is the first step? First step is we want to design the array. Okay, what is the dimension of the array? See here I and j. So I and j, or the going to be the varying parameter. So there are two varying parameter, which means I am going to design 2D array. Okay, now the next thing is I want to design what is its dimensions, what is the length of the array. So see here, I is starting from 0 and going up to where? It will be going up to j minus 1. If it goes to j, then it will be what? It will be returning 1. If it is goes greater than j, it is also returning 0, which means I will be going from 0 up to j minus 1. What is mean by j minus 1? J can go up to what? Go up to n minus 1. So instead of j, just substitute n minus 1, which is equal to n minus 2, which means I want in my I, in my row, it will be starting from 0, 1, 2, going up to where? Going up to n minus 2. Okay, fine. Now j also will be starting from n minus 1 and going up to I plus 1, which means go up to 1 only. So 1, 2, go up to n minus 1. So this is going to be your matrix, but now I want you to understand matrix is always start with 0th index. So here you want to design n minus 2 cross n minus 1, sorry, n minus 1 cross n. So this is going to be your matrix dimension. Okay, fine. Now the next thing is you want to focus on what is going to be the each and every table value. See here, what is the return value of each and every function. So here it is returning 1, and here it is returning 3, and here it is returning 5, and here in some edge cases it will be, sorry, in some base condition it will be returning 0 also. But there is no return value which is negative, which is infinity, or which is minus infinity, or which is null. So you can substitute any values here. Okay, you can either substitute minus 1, minus 2, minus 3, or null, or infinity, or minus infinity, that's your wish. But that value should be every cell. Okay, so here let me assume like minus 1. Let me keep as minus 1. Fine. Okay, so this is the first step. The next step is, just see here, I want to add one more base condition here. So what is the one more base condition? If dp of I and j is not equal to minus 1, because here I initialize everything as minus 1, right? Then just to return dp of I and j. That's it. Okay, and then at last I want to add one more line. Instead of returning simply, we want to return after updating it. That's it. Okay, so here I am just updating it. Here I am just checking whether it is computed already or not. If it is not computed, if it is computed already, then don't go to its below body of the recursion. Just return there itself. Okay, now tell me what is going to time complexity. So time complexity will be O of n square, and space complexity will be O of n square. So this is going to be a time and space complexity analysis. Now many will be having a doubt, hey, can I design n cross n as a matrix as a whole? Yes, you can. Okay, that's not a worry in your memorization technique. When you are going for a tabulation, then you want to design exactly. I'll be telling that around. Okay, now just see here, let me show you the code. So see here, this is going to your code. Now, so instead of dp, I am just written as memo. Okay, so here you can either put like n cross n, or you can also put like n minus 1 cross n. That's your wish. Okay, and filled everything as minus 1 here. If you want, you can fill it with infinity or minus infinity or null. That's your wish. Or minus 2, minus 3. That's your wish. Okay, then here I have had one more line, and here I just written the value, right? Before that I will be storing that. You can either store like this, or as I mentioned in the drawing explanation, you can just store in result, and at last you will be storing that in my result, in my dp array. Okay, you can either do like that or do like that. Simple syntax. Okay, that's it. So this is going to be your entire memorization code. Now let me take this. Next thing we are moving is tabulation. So before moving into tabulation, tell me, there are two things which are affecting my space complexity. So they are, one is my recursion stack, and another one is because of my matrix I used. Okay, so First, let me eliminate this recursion stack. Then let me think about this matrix. So to remove this recursion stack, I want to remove the recursion. If I remove the recursion, then the recursion stack will be automatically removed, right? So what is the third thing? It is tabulation. Fine. Now what I am going to do now? See here, the first thing is I want to check whether I want to modify anything in my matrix or not. So my matrix is n minus 1 cross n, hats off now, right? And then look at the base condition always. So what these two base condition is telling me? These two base condition is, if my I is equal to j, then I want to return 1. Else I want to return, else if it is I is greater than j, then I want to return 0. Okay. Now from here I can tell you I and j will be same, hats off now. Then I want to just make my matrix dimension as n cross n. Why? Because I and j are same. Hats off now, from my memorization I have 0, 1, 2 going up to where? N minus 2 only. But for my I value, it will be going up to n minus 1. Then here also it should be n minus 1. Because I and j are same in my one of the base condition, right? Okay. So whenever there is a I and j are same, then I want to just return what? Return 1, which means for 0, 0, I will be marking it as 1, initializing at 1. And 1, 1 means I will be initializing as 1. Similarly, for n minus 1 means n minus 1 and n minus 1. This particular cell I want to initialize as 1. Can you understand this? So this is going to be your first step. Remaining under, just keep as 0 or don't initialize anything. Okay. So the first step is, wherever the I and j, wherever the row and column number are same, just initialize as 1. That's going to be your first step. Okay. Now this particular base condition, for this particular base condition, let us see in the body itself. Okay, because this base condition is not returning 0, it is like not considering that. Okay, I will be telling you that. Now skip this base condition which I have added in the memorization technique. Now rest of them is a body, right? So whenever we reach the body, I want to use the looping. So to avoid the recursion, we are just going to use the looping. Okay, so for what is the varying parameter? I. So I will be starting from where to where? It is starting from 0 and going up to where? It will be going up to n minus 1. It will be going up to n minus 1, which means now when you are writing in this, you want to write like I is starting from n minus 1 and going up to 0. Okay, sorry. I will be starting from where? Will be starting from 0 and going up to where? N minus 2 only. It will be not going to the furthermore, right? So listen this carefully. So this is what in terms of recursion. In terms of tabulation, you want to do in a reverse fashion. So it will be starting from n minus 2 and going up to where? It will be going up to 0. Similarly for j will be starting from where to where? So j will be depending on I. Okay. So you can either write the outermost as j and innermost as I, or you can also do in a reverse fashion also. That's your wish. Okay. So j will be starting from where? It will be starting from n minus 1 and going up to where? Going up to I. So when I am writing in a reverse fashion, it will be from I plus 1 and going up to where? N minus 1. Can you understand this? Okay. Now comes to the body of the recursion. So if my s of I is equal to s of j, then what should I do? I will be just storing dp of I and j is equal to 2 plus, here comes a recursion call. Whenever there is a recursion call, convert it into a dp of I plus 1, and here comes j minus 1. Okay. Similarly else what should I put? dp of I and j is equal to maximum among dp of I plus 1 and j, comma dp of I and j minus 1. That's it. Okay. At last, what should I return after finishing entire for loop? What should I return? Just to return dp of, see here what I am returning, LPS of 0, n minus 1. Then here I should return dp of 0, n minus 1. That's it. Okay. Now tell me what is going to time complexity. Time complexity will be O of n square and space complexity will be O of n square. But now in this space we are not included. we are not included the recursion stack. It is only because of the matrix we have used. Fine. So this is going to be your tabulation technique. So see here, this is going to be your tabulation code. Now here, so let me modify this. Okay. Now, so I designed a DP array as n cross n, and then for all the same row and same column, I want to initialize as 1. That's the reason I initialize as 1 here. Okay. Now I was starting from n minus 2 up to 0, and here I plus 1 up to n minus 1 for j. And then here I am checking this, and here whenever there is a recursion call, I want to replace this as DP array, and here also similarly DP array, and here also similarly DP array, and then at last also just convert the recursion call into a DP array. That's it. Can you understand this? Okay. Now let me take this and go with the space optimization technique. So what is meant by space optimization technique? See here, in our previous approach, in your tabulation approach, we used the entire n cross n matrix, right? So now we are going to check whether we want that matrix or not. Okay, so that's going to be my space optimization approach. Okay, how I am going to check it? So see here, first of all, check the inner loop always. So in inner loop, I used dp of I and j. Here dp of I plus 1 and j minus 1. And here also dp of I and j, and here dp of I plus 1 and j, and here dp of I and j minus 1, which means I only used dp of I and dp of j, sorry, I plus 1, which means I used only the current row and the next row. So why should I take all the n rows? Why should I take all the n rows when I have these two things? So instead of taking n cross n matrix, I am going to take two arrays of n size. That's it. Can you understand this? Yes. So this is going to be your entire thing to replace this particular line. Okay. Now here for this, what it signifies, it is like dp of I and I is equal to 1, which means in my next the last thing is going to be 1. Can you understand this? Okay, fine. So this is what you want to do for this particular point, or you can either put everything as 1, that's your wish. Or you can also put the last thing alone as 1, because that's the thing alone we need for this particular iteration. That's the reason I am putting like that. Okay. Now see here, in between these two for loops, I want to put one more line like current of that particular index alone will be equal to 1. Can you understand this? Wherever I go, that particular index alone I want to replace as 1 because of the base condition. Okay. Now go to the inner loop. Wherever it is dp of I, just convert into current. Wherever there is dp of I plus 1, just convert into next. Similarly here also convert into next, which means next of j, and here it is current of j minus 1, and here it will be current of j. And then after finishing this inner for loop, I want to assign my next as current. So this line is very important. At last, what should I return? So here you can either return current of n minus 1, or you can either return next of n minus 1. That's your wish. Okay. So what I basically did is, instead of taking the n rows, first of all I am taking only these last two rows. By using this, I will be computing this particular row. Now I will be taking these two rows. By using this, I will be computing this row. Again I will be taking another two rows, and at last I will be finding out the 0th row's answer, and at that 0th row I will be returning it. That's the reason why here, instead of dp of 0, I replace them as current or next. Now tell me, what is the time complexity? It will be O of n square, but space complexity will be only of O of n. That's it. So this is called the space optimization technique. Now see here, let me show you the code. So see here. So this is going to be your code. So I told you, right, the last element of the next is going to be 1 because of the base condition. In base condition, what they have told, last row, last column should be 1. Here the next means what? Next means the last row. In its last column it should be 1. That's the reason I put here as 1. Can you understand this? Can you understand this? Or you can also put everything as 1. Okay, that's your wish. Okay, now see here, current of I is equal to 1. So what it signifies? Here also it signifies current means it is the current row. So at first it will be n minus 1th row, n minus second row, n minus second row. Okay, and then it will be n minus third row, and it goes on, and it becomes 0th row. When it becomes 0th row, then at my 0th column it should be 1. When my I is n minus second row, in my n minus second column it will be 1, like that. That's the reason I added this line. Okay, now at this particular line it will be dp of I and j, replaces current of j, that's it. And at this line also it will be dp of I plus 1 and j minus 1. Instead of that, just replaces next of j minus 1, that's it. Okay, at last copy my everything in my everything in my current into the next. Okay, and then at last either you can put here as current or you can also put here as next, because both the things are assigned globally. If you assign this current, if you initialize current or declare the current at this particular highlighted part, then you cannot use current here. That's basic syntax. So that's it. And also I want to give you one more approach. When you are going for a technical interview, it is good to give one more approach also, right? So the simplest approach is, if you already gone with longest common subsequence, if you already know about this, then you can also use this in this particular problem. Can you understand this? So what is mean by longest common subsequence? They will be giving you two strings. Among them you want to find the longest common subsequence. So here just to take the same string reverse and find the longest common subsequence, which means just to find LCS of the longest common subsequence of the given string, the input string, and reverse of input string. That's it. If you find this also, it will be the answer for this particular problem, longest palindromic subsequence. Can you understand this? So by using this also you can do. Okay, why I am telling this is, in same interview or in same round, if they ask these both the things, just copy paste that and use that function again and again for 2 times and return its result. That's it. It's easy, right? So you can do like this also. So for this also the time complexity will be same. Okay, so that's it. So we have started from the recursion and completed up to the space optimization technique. And if you have any doubts in this particular code or in this particular drawing explanation, just comment below. And if you really like this video, just like this video, subscribe to my channel, and go and check out my DP series. There are plenty of problems, and you can just solve plenty of problems and take a more practice. Okay, and it will be more helpful when you are going for a technical interviews and as well as the Leetcode contest. Fine. Thank you.